Okay, physics people, we are going to go over our intro notes for the constant velocity unit, or the unit that we call describing motion. So let's get started. You do have guided notes that you can fill out while we go through these slides. And I do recommend using those or taking your own notes that you can refer back to later. So the objectives of this unit, we want to use words, graphs, and numerical relationships like equations to describe constant velocity. We want to demonstrate how to record and represent an object in motion, and we want to demonstrate that observed motion is dependent on a frame of reference. So getting started, a definition you should know already is that the meter is an international unit for measuring distance. So whenever we're talking about velocity, we want to make sure our units are measured in meters. Kilometers is okay too, just make sure that base unit is a meter. Another word to know, this is new to this unit, is the term scalar. So scalar means magnitude only. So here you have a sign that says 50 kilometers per hour. This tells you how fast, but it doesn't tell you in which direction. So this is a scalar representation of a measurement, 50 kilometers per hour. Vector is another new term for this unit, and that is magnitude and direction. So here you have a GPS. It's telling you to go 40 miles per hour in whatever direction this is, but it is telling you a direction and how far to go. So that is an example of a vector. If you hear somebody say, I went 50 kilometers per hour east, that is a vector representation, whereas if they just said I went 50 kilometers per hour, that is a scalar representation. So those are two terms to get familiar with. I like this little video clip. I'm not sure if you guys would be able to hear it, but let's see. This is from Despicable Me. It's a great movie where Vector introduces himself. I'm sorry, Victor. So yeah, if you have a hard time remembering vector, just think of that little clip in Despicable Me. If you couldn't hear it from my computer, I recommend looking it up on YouTube. It's comical. Another definition, magnitude means size. So whenever we say magnitude, we mean how big, how small. And magnitude, here's an example of a vector arrow. An arrow that tells you the direction. You know the direction because of the direction the arrow is pointing. And the magnitude is represented by the size of the arrow. So something that is 50 meters away compared to something that is 30 meters away, the object that is 50 meters away has a greater magnitude and distance. It is farther away from us. It's bigger. That's another term to get familiar with. All right, distance. We will use this term a lot. Distance is how far an object travels along its path. So for distance, we are only concerned about how far and not the direction. So here you have an example, a straight line from point A to point B. That's displacement. We'll come to that term in just a second. But maybe this object went on kind of a path around mountains or trees or something. So to get from point A to point B, they traveled this distance that is represented by the dotted lines. Displacement is the location of an object compared to its original location. That is a vector because you want to know where is it compared to where it started. So here you would say that point B is this distance away, so however far this is, away to the right. So that's a displacement. If I run around a track in a circle and I go all the way around the track, my distance would be 400 meters. I went all the way around the track. But because I started, or I ended where I started, my displacement would be 0 because I'm 0 meters away from the starting point. Something to think about, and we'll have some more examples of that later in this unit. All right, so on the diagram below, mark the origin. The origin is simply the starting point. Okay, so the starting point we've determined at point A. We put a little stick figure there. So we start there and we want to know how far does the stick figure travel around this path. So he goes 2 meters this direction, 4 meters this direction, 2 this direction, and then 4 meters back. So the total distance traveled is 12 meters. You would add 2 plus 4 plus 2 plus 4 and traveled a total of 12 meters. But he ended where he started. So his displacement is 0 meters because he is back to the origin. Keep in mind, 12 meters is a scalar measurement, so it tells us how far. 0 meters for displacement tells us how far and in what direction. In this case, we know that 0 meters away from the origin is in no direction. All right, on this one, we are looking at a skier who travels from point A to point B, back to point C, and then to point D. So the position is the distance and the direction from the origin of the object. So different positions are here. Position A is at 0. Position B is all the way over here at 160 meters. Position C, remember this is from the origin, so position C is 40 meters. And position D is 120 meters. So the skier's total distance traveled, we need to add up all of these distances that he traveled between points. So from point A to point B was 160, point B to point C would be 120 meters, and then point C to point D would be 80 meters. So when you add those up, his total distance traveled is 420 meters. His total displacement, remember displacement means how far you are away from the origin and in what direction. So his total displacement, he ends up at point D, would be 120 meters east. So make sure you have that direction labeled as well. All right, here's one more example. This is kind of that windy path example we talked about earlier. So the total distance traveled, this motorcyclist needs to go from his house to this factory, and he's going to travel along this windy road. So he travels 200 meters to get to that factory. But remember that displacement is the straight line distance and direction from the origin. So the origin would be where he started at the house. So his total displacement is only 120 meters northeast. It's that straight line path. And those are all of your intro notes for today.